Yo, what's up, guys? Welcome back to Learn with Endless. Today, we are going to start with the Unit 1 of Research Methodology, that is Research Fundamentals. So, without any wasting time, let's get started. Unit 1 or Lesson 1 Research Fundamentals. Its learning objectives. After completing this section, students will be able to understand basic research concepts, types, and processes, formulate research problems and objectives systematically, apply appropriate methods and data collection techniques, analyze data and present findings in a structured manner. Meaning and significance of research. Meaning of research, its definition. Research is a highly structured and systematic and objective meticulous search for new knowledge. Core objective. It aims to sift through, dissect, and reinterpret data to gain a deeper understanding of a phenomenon. Sense making. The essence of research is the art of making sense of information, moving beyond just collection data to understand growth patterns or implications, and so on. Distinction. A data collector merely gathers facts, while a researcher analyzes that data to find meaning. Significance of research. Its purpose. To cut through the noise to find the truth, drive understanding, and solve problems. Personal motivation. Thirst for knowledge and thrill of the chase, acquisition of higher degrees, masters, doctorates, career advancement, and social prestige. Societal implications, progress and economy. Research drives innovation, it is efficient, cost cutting, and economic growth. Global issues. It addresses critical challenges like food security, climate change, and disease. Public policy. Foundations for new medicines, technology, and effective public policies are built through research. Requirements and characteristics of research. Characteristics of research. Origin. It begins with a pressing question or an unresolved problem. Goal oriented. Every decision is guided by crystal clear defined goals. It is systematic. It follows a well organized plan called the research design or methodology. It is empirical and clinical. It relies on hard data. The conclusion of one study often fires the imagination for new questions, creating a continuous cycle. Objective. Researchers must avoid personal prejudices that might bias data gathering or interpretation. Verifiable. Results must be presented clearly so others can check the accuracy. Replicable. Other researchers should be able to repeat the study and arrive at a similar conclusion. Qualities of a research. Qualities of research are inquisitive mind, ethical core, critical but open-minded, persistent, subject expertise. Let's discuss them one by one. Driven by why and how to get to the bottom of things. Ethical core, guided by the honesty, which includes giving proper credit and being truthful about the research. Critical but open-minded, able to smash assumptions while remaining open to fresh ideas. Persistence, the ability to handle failures, setbacks, and dead ends is essential. Subject expertise, one must know the existing literature to spot gaps in the knowledge. Next topic, types of research. Research is classified by its purpose, method, and type of information it collects. Let's discuss these type of classifications one by one. Classification of by purpose. It is divided into two parts: basic fundamental research and applied research. Let's discuss them one by one. Fundamental research, driven by the thirst for knowledge and theory development, it seeks to push boundaries rather than solve an immediate practical problem. Example: a biologist studying how a protein folds. Uh, sorry, sorry, sorry. It's not science. Applied research, concerned with real world issues and practical applications to solve immediate problems. Example, designing a drug to cure a disease based on biologists' findings. Next topic, classification by method. It is divided into four parts: analytical research, conceptual research, exploratory research, and descriptive research. Let's go through them one by one. Analytical research scrutinize existing information through logical reasoning to understand why and how things happen. It's often used in finance or economics. Conceptual research, connected to the abstract ideas or theories often used by philosophers and thinkers to develop new concepts or reinterpret existing ones. Exploratory research, an initial investigation in areas with little previous study to gain preliminary insights. Descriptive research provides a clear picture of a situation, such as case study. Next topic, classification by data type. Quantitative research. It is divided into three parts: quantitative research, qualitative research, and mixed research methods. Let's go through them one by one. Quantitative research uses numerical data, large samples, and standardized instruments to test hypotheses. It is confirmatory and deductive. Example, a survey of 1,000 voters to predict an election. Qualitative research focuses on textual or image based information to explore phenomena deeply. It is exploratory and inductive. Example, one on one in depth interviews with a small group. Mixed method research combines both quantitative and qualitative data to provide a comprehensive view of the problem. Next topic, the research progress process. The research process is defined as a systematic procedure consisting of a series of critical, often overlapping steps. It is inherently clinical, meaning the conclusions of one study frequently spark new questions that drive further investigation. Core steps of research progress. First, identify the problem. Moving from a broad area of interest to a focused, researchable question. That is the most critical stage as it sets the project's tone. Second step, literature review. Examining existing work to avoid reinventing the wheel. This helps identify gaps in the current knowledge and learn from other methodologies. Step 3, state goals and hypotheses. During the overarching goal, specific objectives, actions, and or such hypotheses, a detailed prediction of how variables will relate. Step 4, methodological plan, creating the blueprint or the protocol for the study, including the research design, example, experimental versus descriptive, and the tools to be used, data collection and analysis. Step 5, gathering empirical evidence and using statistical or thematic methods to find meaning. Step 6, reporting findings, summarizing the output and connecting results back to the original problem or theory. Next topic, induction and deduction in research. Research logic follows two primary paths, often integrated into a single scientific method, and these are deductive reasoning, top to down. Its direction moved from journal theory to a specific observation process. It begins with an established theory, develops a hypothesis, and then collects data to see if the hypothesis is supported. Application closely associated with quantitative research, confirmatory approach. Its limitation. If the starting premises are false, the conclusion will be wrong, even if the logic is perfect. Inductive reasoning, from bottom to up. Its direction, from its specific observation to journal theories or patterns. Process. It starts with an observation of specific cases and draws conclusions about the whole classes of events. Its application closely associated with I'm sorry, application closely associated with qualitative research, exploratory approach, its limitations. Conclusions are based on probability, not certainty. A single black swan exception can disprove an entire inductive theory. Wait a second, guys. Water break. I need a water break. Mm. Okay. Now, next topic, mm, the hypothetical deductive method. Modern science typically combines both logic into cycle known as the engine of research process. Huh? Induction. Let's go through them one by one. Induction. Observation. Noticing a specific pattern or phenomenon in the environment. Induction. Hypothesis. Developing a best guess or general theory based on those facts. Deduction. Prediction. Make a specific testable prediction. Example. If x is reduced, then y will drop. It's a simple linear equation. Basically, you guys can understand. Testing. Conducting experiments to prove or disapprove the prediction. Here is a tip for you guys. Remember that deductive logic focuses on testing theories, confirmatory and quantitative, while induction logic focuses on building theories, exploratory or qualitative. And guys, if you want notes, you can join my Telegram for further information, or you can just simply watch the video and get the notes for free. Next topic, Introduction to Research Tools. Research tools are the instruments used to collect, organize, and analyze information. Choosing the right tool is essential for ensuring the validity and rigor of your study. Literature search tools. And here are some literature search tools: bibliographical databases, academic search engine, citation chain. Let's go through them one by one. Bibliographical, bibliographic databases, specialized digital libraries that house scholarly articles. Example: PubMed, it's for biological sciences. ERIC and PsycInfo, psychology and information. Distro, General Academic, and INSPC, Inspect, for injury. Academic search engines. Tools like Google Scholar will allow for broad searches across various disciplines. Citation chain, a technique used to find seminal references by looking at the bibliography of a key paper and tracking its source back in time. Visualization and analysis tools. Uh, uh, these are mind mapping and brainstorming conceptual framework. Let's discuss them one by one in detail. Used to break mind mapping and brainstorming. Used to break down broad subjects into manageable chunks and organize thoughts before starting the formal investigation. Conceptual framework. A visual map, often a diagram, that shows that the relationship between key players, theories, and concepts in your research. Statistical tools. Uh, Descriptive statistics and inferential statistics. Let's discuss them one by one. Descriptive statistics, tools used to summarize data through measures of central tendency, mean median mode, and variability, standard deviation, and range. Inferential statistics, tools used to answer so what by determining the question so what by determining if the findings are statistically significant or just occurred by chance. Let's discuss a case study that will help us understand these topics in detail. So let's get started. Case study: the Learn Fast notification study. To help you prepare for the exam, use this case study to explain how a researcher moves through the process using different tools and methods. So let's get started. Dr. Anna, an educational psychologist, noticed a trend. Students' anxiety seemed to spike when schools learn fast digital platform send frequent notifications. This was the observation. Identifying the problem and gap. Initial search. Dr. Anna searched databases like ERIC and PsycInfo. It is a psychological study. You guys can understand. The gap. She found plenty of research on screen time, the context, but nothing on how specific notification techniques affected students. By applying logic, the hypothetic deductive method we have discussed above, she induced that based on her observations of students, she developed a theory that digital interpretations cause anxiety. She reached a deduction that she predicted if the notification frequency is reduced, then the students' anxiety scores will drop. The research method and tools. Method. She used a mixed method research approach. Quantitative. She used statistical rigor to establish a cause and effect relationship. Qualitative. Conducted interviews to understand the students' personal experiences, outcome, and ethics. Dr. Anna's study represents a systematic search for truth, maintaining objectivity by not just guessing but using hard data to help us students. Here's a tip for you guys. Again, it's a short summary tip. Quantitative techniques are the confirmatory research tools, examples, numbers, large samples, and qualitatives are for exploratory research, text, deep meanings, etc. Mixed methods are combination of both for a broad view or a comprehensive view. Here is a quiz for you guys. Which I have solved it, but you can just still go through it. Research is the best defined as piling up hazards in one place, hazard पे या directly करते हैं छोड़. Research is the best defined as a systematic process of sense making to understand a phenomenon. Which character of research ensures that someone else could theoretically repeat the study and arrive at the same conclusion? Well, guys, if you want to challenge yourself, watch the video, then try this again while pausing the video. Answer is B, replicability. Basic research is primarily driven by A. Need to solve specific practical problems. B. A thirst for knowledge and the development of theories. C. Economic and financial matters. Answer is B. A thirst for knowledge and development of theories. Which type of research is the only way to prove cause and effect relationship? Answer is B. Experimental research. An epidemiologist looking back at the past medical history of patients with disease is conducted. A retrospective research is a specific research. Qualitative research is best described as it is the touchy feeling, exploratory, and inducer. Hmm. In the research process, what steps follow identifying problems? Do a research literature review. Deducting reasoning moves from journal to specific. Which research tools helps reduce complexity of word and allows abstraction? It's statistics. Which type of statistics answer the question? What is my data? Example, mean, median, mode. It is descriptive statistics. Yeah. With this, we are over with Unit 1. Good morning, guys. Welcome back to Learn with Endless. Today, we are going to start with the Unit 2 of the course Research Methodology. The Unit 2 is problem identification. So, without any wasting time, let's get started. Hope you guys subscribe to my channel and share this video with friends. Do watch Unit 1 and for the reference, as we have discussed the important case study in Unit 1. This case study's reference will be followed through in all the after videos and units. So do watch that case study. It is an important case study. तुम लोगों को रेफरेंस समझ नहीं आएंगे अगर तुम यूनिट देखोगे वो वाली यूनिट वन वाली वीडियो देखोगे नहीं कि उसी केस स्टडी पे आ गए ओके बाकी लेट्स गेट स्टार्टेड यूनिट टू प्रॉब्लम आइडेंटिफिकेशन by the end of the section you guys will be able to understand the basic concept types and process involved in research formulate research problems objective in clear systematic manner applying appropriate methods for research and data collection analyze and present research data within a structured framework. Next topic, choosing an appropriate problem area. Identify a good problem is the heart of every research project. A well chosen problem has the potential to push the current boundaries of knowledge. Sources of research problem. Personal experience and observation, existing literature, professional guidance, conferences, global and economic issues, funding requests. Let's discuss them one by one. First, personal experience and observation. Daily life and professional practice are rich with inspiration and natural human curiosity about why things happen. Second, existing literature. Reviewing books and articles help identify blanks, knowledge gaps, resolve existing debates, or addresses excellent areas of sorry, concept of concern. 3. Professional guidance. Mentors, professors, and experts provide insights into valuable research area. Number 4. Conferences. Attending these helps determine current trends, what's in and what's out in a specific field. Global and economic issues. Problems can be found in brand new technologies, economic crisis, or global challenges. Just like the recent economic war situation, due to that, there are global issue challenges about LPG and such. Funding requests, grant proposals from agencies often list specific problems they are willing to finance. You can say it's WTO. Characteristics of a good research problem: clarity, feasibility, significance, complexity. Let's discuss them one by one. It should be thoroughly thought out. Clarity. It should be thoroughly thought out and clearly stateable in a single sentence. Feasibility. The researcher must consider the time, cost, available tools, data, and his own personal ability. Significant. The problem must be worth the effort. Complexity. Problems that are too simple, yes or no answers, require minimal work, or merely compare two sets of data are not suitable for university level research. Next topic, identifying sources of research article. To understand a problem, finding relevant literature is the key to success. Key sources. Number one, library resources. Number two, bibliographical databases. Number three, academic searches. Let's just see them one by one. Library resources. Physical and digital catalogs, reference librarians, and interlibrary loan service. Bibliographical databases. They're the most effective weapons for managing large volumes of research. Here are some examples. PubMed, Life Sciences, Eric Education, PsycInfo Psychology, Gesture slash Web of Science, Journal Academic. Number three, academic search engines. Tools like Google Scholar are helpful but require researchers to be cautious about the reliability and credibility of the sources. Search strategy. Citation chaining. This is an important topic. Uh, Citation chaining. This is a highly effective strategy where researchers use reference list or reference article they have already found to track down classic or seminal references cited by multiple authors. Next topic, the literature review, stating and evaluating the problem. A literature review is not merely a dry summary of what has been written, but it is a critical analysis that provides a rationale for your study. It involves dissecting existing knowledge to build a solid base for your investigation. Here are the three essential elements of a problem statement. When writing the problem statement within your Literature review. You must address these three specific components to justify your research, and they are the context, the gap, and the contribution. Let's discuss them one by one. The context. What is known? It is what is known. This provides the big picture or broad background of the topic. It outlines the theoretical underpinnings and established facts in the field. The gap, the unknown or the controversial state. This is the most critical part of the state. It identifies what is missing, unresolved, or controversial in the current body of literature. Its goal is to show a hole in the knowledge exists that justifies a new study. This often motivates the researchers. The contribution, filling the gap. This explains how your research will address the identified gap. It links your specific research objectives to the broad context you established earlier. Next topic, evaluating sources, quality and credibility. Not all sources are equal. A researcher must evaluate material based on specific criteria to ensure high quality research. Primary versus secondary sources. Primary sources. Original reports of a study, such as journal articles containing raw data or first-hand accounts. Secondary sources. Summaries, interpretations, or reviews of primary data. Example. Textbooks, encyclopedias, and review articles. Peer review. Preferred because the sources have been scrutinized by impartial experts before being published. Its objectivity. The source should be impartial, avoid materials that are shilling for a cause or produced by companies with a conflict of interest. Example, a sale driven blog post. Obviously, they will focus only on the good side, not on the bad side. Timelessness, evaluating how the recent information is to ensure that it is still relevant to the current state of the art in the field. Let's discuss another case study. Case study, the interface project for smart face system researcher. Anna, I'm taking the name Anna again. She is a master student in in agricultural informatics. Let's discuss. Let's discuss this. Down, down. Identify the area of concern. Observation. Having grown up on a farm, Anna noticed a recurring practical issue. Many farmers purchase high-tech soil sensors, but rarely use the accompanying software. The root cause Anna identified was that the software interfaces were overly complex and required a constant high-speed internet connection, something unavailable in remote agricultural areas. She reached a validation. She confirmed that this was a significant professional practice problem by consulting with her professor, peers, and local extension workers, who all agreed it was a widespread issue. Formulating the problem statement. Anna moved beyond simple yes no questions to create a formal, researchable statement. Current agriculture sensor interfaces are not optimized for offline, low literacy users in remote areas, which means the soil data is not being used as much as it could. Searching the literature and state of art. Objective to determine the pinnacle of knowledge and find holes in the maps, basically the gaps that her research could fill. She used tools like specialized database. She used Agricola for agriculture and likely Web of Science for the informatics. Search strategies. She used specific keywords like user interface, agriculture, and office computing. Citation chain. Anna looked at the bibliographies of her initial findings to track down seminal or classic works that define the field. Identifying the research gaps. Through her review, Anna found three distinct piles of information. Context. Significant research existed on soil sensors and journal interface design. The gap. She found a major lack of research specifically addressing offline data visualization for users with low literacy. In agriculture setting, the contribution or project goals become bridging the specific gap by adding new usability knowledge to the field of agriculture informatics. Uh, Here's the summary for this case study: practical versus theory. It shows how a research problem can stem from real world practical issues. That was basically farmers' needs in this case. Systematic approach. Anna didn't just guess. She used specialized databases and citation chaining to ensure that her work was built on solid foundation. Defining the gap. The most critical part of the study was finding the hole in the map, the specific area, offline, low literacy usability that no one had thoroughly researched yet. Here is a tip for you guys. A literature review is a methodological investigation to find, evaluate, and stitch together everything written on subject. What is common pitfall? A report that only provides raw facts without interpretation, answering the so what is incomplete. What is primary to? Use citation chaining to find seminal or classical reference that many other researchers have cited. Let's go to the new topic: techniques and methodology. In research, there is a fundamental distinction between how of the small tasks and how of the entire project. Techniques refers to the small practical and specific steps used to identify and break down a particular research problem. Methodologies. These are the overarching systematic approaches that govern the entire research project from start to finish. Water break. Where was that? Yeah, 2.51. New topic. Next topic. Next topic. Uh, Techniques for problem and literature analysis. Effective techniques are essential for gaining a grasp on complex subject before formal data collection begins. Keywords and synonym generation. Process. Break the subject down into main key points, then hone in on core areas. Expansion. Generate synonyms and related terms to be used in library searches. And its outcome, as the initial search progresses, new words are discovered, and the researcher's understanding of the issue grows. Conceptual framework. It is a visualization tool that acts as a map for the research. Its format is often represented as a diagram showing the relationships between key players, theories, concepts, and variables. Its purpose. It clarifies what the researcher believes and establishes the logic of the study. Next topic: journal research methodology. The methodologies are generally characterized based on the type of data they use or the style of the investigation. These are basically divided into data type, style. Let's discuss them in detail one by one. Classification by data type. It is further divided into three types, as we have discussed earlier: quantitative research, qualitative research, mixed methods research. Quantitative research, its nature is objective and confirmatory. Its main focus is on numerical data and statistics to test hypotheses and generalize results for a larger population. Qualitative research, its main nature is exploratory and inductive, and its main focus involves non-numeric data, images, texts, observations to deeply understand a phenomenon. Mixed methods are integration of both the qualitative and quantitative data to provide a more comprehensive and broader view of the problem. Next, next is the classification by style. It is divided into three: formal research, analytic research, constructive research. Formal research. It uses a style relying on basic truth, axioms, and logical proof. Analytic research using an experimental style to determine why the things are the way they are by scrutinizing the information through logical reasoning. Constructive research, design research, focuses on building an artifact such as a piece of software, tool, or a new process to solve a problem. Here is the summary for you guys. Difference between technique and mobility. A technique is a step, like man-made. Methodology is an approach, like quantitative. Key to. It is what is key to. The conceptual framework is a visual diagram essential for showing how different concepts in your study relate to one another. Research style. Be prepared to differentiate between formal logic/actions, analytic, logical reasoning, experimental, and constructive artifact building styles. नेक्स्ट टॉपिक सब्जेक्ट है तो सही इंटरेस्टिंग है लेकिन लंबा वाला है छोड़ो मतलब वेयर वर वी हाँ 2.6 अंडरस्टैंडिंग द स्टेट ऑफ आर्ट द टर्म state of art refers to the highest level of development, knowledge, or technology reached at any particular time in a specific field. In a research paper or thesis, this section represents the boundary of current human knowledge. Purpose. The purpose of the state of art review: defining boundaries, identifying gaps, establishing credibility, avoid redundancy. Let's discuss them one by one. Defining boundaries. It shows the researcher exactly where the frontier of the knowledge lies. Identifying gaps. By summarizing what is known, it becomes easier to spot the holes in the map, unresolved problems, or exploratory areas. Establishing credibility. It proves to the examiner that a researcher is fully aware of the recent advancements and is not reinventing the wheel. Avoiding redundancy. It ensures the researcher does not waste time solving a problem that has already been solved by someone else. Next topic. Key methodology systematic review system. मतलब systematic literature review. To establish the state of art, researchers often use a systematic literature review. Let's go through its definition. A protocol based methodological synthesis of all studies related to a specific issue. Process. It involves taking an issue part piece by piece through a methodological investigation of all existing literature. Outcome. It provides a comprehensive, objective overview rather than just a hazardous collection of facts. Establishing the state of art requires a systematic literature review. Unlike a casual reading, an SLR is protocol based. It follows a certain strict section of rules for searching selected papers. Comprehensive, it aims to find all high relevant quality studies on specific issues synthesized. It doesn't just list papers, but stitches them together to form a coherent story of the current field. Here's the case study we have discussed earlier, the Smart Farm Interface Project. This case study illustrates how the researcher uses the state of art to justify their project. The researcher, we have Gochara Dana, a student, a master student in agriculture and informatics, noticed that while soil sensors hardware were advanced, the software interfaces were too complex for farmers in remote areas who lacked high internet speeds and they had low level literacy rates. Investigating the state of arts, Anna conducted a systematic review to find the pinnacle of current knowledge. She used databases like Agricola for agriculture sector and Gesto for general sciences or engineering to look for the current trends in soil sensors, the current standards in UI user interface designed for rural population, existing offline for data synchronizing methods, identifying the gap by taking apart the issue piece by piece. Anna realized that the content there were 500 plus papers on sensor accuracy and 200 plus on general UI design. The gap. There were almost zero research on offline visualization data representation for low level farmers. Contribution. By defining the state of art, Anna proved that her project, building a simplified offline capable interface, was not just a good idea, but a necessary scientific contribution because it filled a specific hole gap in the map that no one else had addressed. Let's Here's again tip for you guys. We have discussed earlier. Let's discuss again. Definition of state of art. If asked to define state of art, describe it as an exemplary level of development in a field. Water break. The gap. Always emphasize that the primary goal of reviewing the state of art is to find research gap. Case study tip. If asked for an example, use Anna's Smart Farm project to show the transition from broad content to a specific gap to contribute to unique contribution. Here's a quiz. Here's a quiz for you guys again for Unit 2, just like Unit 1. Which of the following is not described as a suitable type of problem for research project? C. A problem that boils down to simple yes no answer. And here's an explanation for you guys. Research problems should be complex. If they can be solved with a simple yes or no, they lack the depth required for university level investigation. Which bibliographical database is best suited for research in life science? As we have discussed again and again, it's PubMed, as it is a database special for specialized data for biological and life sciences. In context of literature review, what does the context section primarily establish? It see the broad picture and theoretical underpinnings of the topic. The context provides a big picture of what is already known before identifying what is missing. 4. Which type of research relies heavily on experimental method to test hypotheses about cause and effect? It is analytic research, as it uses logical reasoning and experimental styles to determine why the things happen. What is defining characteristics of qualitative research? It involves non-numerical data and is exploratory and inductive. This was an exam tip for you guys too. Important fact. Uh, Qualitative research focuses on textual or visual information to explore the phenomena deeply rather than just using numerical data. 6. Which source tactic involves tracking down references that are cited by many other researchers? Citation chaining. Citation chaining involves using papers bibliography to find seminal or foundation work in the field. 7. What does peer review ensure regarding a research process, research source? The source was scrutinized by impartial experts pre-publication. Peer review involves checking experts checking the approach, truthfulness, and result before they are published. Number 8. Constructive research is most commonly associated with which field? Engineering and informatics. Constructive research focuses on building artifacts such as software or prototype, which is staple for engineering and information informatics. Number 9. What is primary purpose of state of art review? Its main purpose is to identify the current boundaries and pinnacle of knowledge because it helps researchers find the frontier of knowledge and pinpoint specific gaps that need filling. In Anna's case study, which was identified as gap, offline data visualization for low literacy farmers, while the journal info context was available. The specific lack of research for the offline visualization for this user formed the gap. With this, we are done with unit 2. If you guys like my video, do share with your friends and subscribe to my channel. This is a whole long video. I know, guys, you guys must be bored, but this is these videos essentially cover all the topics available for your exam. I can't assure you. I can somewhat assure you if you guys learn from my videos, you will score more than 9 GPA. But यहाँ तो रट्टा मारना पड़ेगा बहुत लंबा टॉपिक है. This topic is too long and quite boring actually. Anyway, all the best for the exam. मेरा भी है वैसे तो. Well, thanks for watching. Share कर देना video. Let's see you guys on another video. In the next video, we will start with Unit 3. बाकी वीडियो भी देख लेना। अगर सिस्टमेटिक वे में पढ़ोगे तभी याद रहेगा। अगर बीच बीच की यूनिट देखोगे तो समझ भी कुछ नहीं आएगा, क्योंकि कॉन्सेप्ट सारा मिलता हुआ है। बाकी जिसको आ जाता है बढ़िया, उसका दिमाग अच्छा है। मेरा तो नहीं है भाई। ठीक है, थैंक्स फॉर वॉचिंग, सी यू सून, बाय। Hello everyone, welcome back to Learn Win Endless. Today I'm going to start with the unit 3 of the topic research pathology. So without any wasting time, let's get started. Unit 3, Data Analytics. Learning Objectives. By the end of this lesson, students should be able to explore and organize large data sets effectively, understand the pre-processing steps required for before analysis, select and apply appropriate descriptive statistics, center tendency variability situation, apply inferential statistics to estimate population parameters and test hypotheses. Introduction. The search and meaning in numbers. Data analytics is described as the process of interrogating data to find the story it is trying to tell. It moved beyond the simple calculation to interpretation. The analysis role. The analyst's role. The researcher must act as a detective, looking for patterns, outliers, and relationships that aren't immediately obvious. The so what factor. The ultimate goal of analytics is to cut through the numerical noise to understand the meaning and implications of the finding. For example, focus on the analytic mindset and the transition from raw data to actionable information. Introduction. Again, the purpose of analytics. Interrogating of data. Raw data versus information. The so what factor. Interrogation of data. The analytic acts as a detective asking for data to find the story it is trying to tell. Raw data. Raw data is a collection of numbers or facts. Analytics transform this raw data into information, meaningful patterns, and eventually into knowledge, insights that can be derived through the so what factor. The most critical aspect of analytics is moving beyond the what, the numbers, and to the so what, the applications of those numbers for research. The analyst mindset. As a successful researcher must approach data with specific mental framework. Objectivity. The analyst must not look for the data that only supports the hypothesis, but must remain open to what the data actually shows. Practices. One must always question the source of the data and the methods used to collect it. Attention to the detail. Identifying outliers, the usual data points, is essential, as these points often hold the most interesting insight or reveal errors in the collection process. Descriptive versus inferential thinking. Analytics is broadly divided into two logical stages that a researcher must navigate: descriptive analysis and inferential analysis. Let's go through descriptive analysis first. Focusing on what happened and what is my data. It uses measures like mean, median, and mode to summarize the current data sheet. Inferential analytics focuses on what does this mean for the wider group. It uses sample data to make predictions or generalizes about the larger population. Exam summary. Conceptual definition. In an exam, the data analysis as a process of transforming raw data into meaningful insights. The detective metaphor. Use the idea of detective or interrogator to explain the proactive role of the researcher. The bridge. This topic serves as the bridge between the Unit 2 and the rest of the Unit 3. This is the analytic study tip. Always emphasizes that data does not speak for itself. It requires human researcher to interpret it through the structured methodology to avoid bias and ensure accuracy. Next topic, exploring and organizing a data set. Before performing advanced statistics, the data must be cleaned and organized. This stage is often called data preprocessing, data cleaning, or data preprocessing. Handling missing values, identifying outliers, consistency. Let's go through them one by one. Handling missing values. Deciding whether to delete incomplete records or use statistical methods to fill in the gaps. Identifying outliers. Finding data points that are significantly different from the rest of the set, which could indicate errors or unique phenomena. Consistency check. Ensuring that data is recorded in a uniform format. Example, all the data in the same format, all measurements in the same unit. Organizing data for analysis. Tabulation, coding, or data visualization. Initial. Tabulation, arranging raw data into columns, rows to make it readable. Coding. Assigning numerical values to qualitative categories. Example, coding male as 1 and female as 2 to allow for mathematical processing. Data visualization. Initially, using simple tools like frequency tables or histogram to see the shape of the data before applying formulas. The danger of black box analysis. The material warns against the relying solely on computer software like SPSS without first looking at the data. A researcher must understand the logic behind the numbers to avoid making incorrect inferences based on software errors or misentered data. Example, key concept. Data analysis is a systematic process of sense making. Critical step. Never skip pre-processing, analyzing dirty data leads to dirty results, garbage in and garbage out. Two listings. Use descriptive statistics to summarize what is your data and inferential statistics to make predictions about the wider population. Next topic. Choosing the appropriate statistics. Full coverage. Stati- Statistical analysis is generally divided into three levels of complexity: descriptive, associational, and inferential. Descriptive statistics, the fundamental. These two describe the basic features of data in a study. They provide simple summaries about sample and the measures, measures of central tendency, mean, median, and mode. Mean, the arithmetic average, it is highly sensitive to extreme values, outliers. Median, the exact middle value when data is ranked. It is the best measure for skewed data like income levels. Example, income level. Mode, the most frequently occurred value, useful for categorical data. Example, the most popular car color. Measures of dispersion spread. Range, standard deviation, variance. Range, the gap between the highest and lowest value. Maximum, minimum, minimum. Standard deviation, also called as the most important measure of the spread. It tells you how much, on average, the data points stray from the mean. Variance, the square of the standard deviation. And here's the diagram for better representation. Symmetric mean, median, mode. Mhm. Measures of association, relationship. These statistics explore how two or more variables relate to one another. Correlation, Pearson's measure the strength and the direction of linear relationship between two variables. Range, minus, plus minus, less than 1, perfect negative, plus 1, perfect positive, 0 means no relation. Regression analysis used to predict the value of dependent variable based on the value at least one independent variable. Example, predicting exam score based on R study. Inferential statistics generalizing. These allow researchers to use sample data to make generalizations or inferences about the larger population. Hypothesis testing. P-values. The p-values tells you the probability about your result happened by pure chance. In most significant research, a p-value greater than 0.05 is considered statistically significant, meaning there is 95% chance the result is real. The t-test compares the means of two groups. Example, comparing the average test scores of group A versus group B. ANOVA, analysis of variance used when comparing the mean of three or more groups. Next topic, the normal distribution, the bell curve. For many of the statistics above to work, especially parametric tests, the data should ideally follow a normal distribution. Symmetry. The left and right sides are mirror images. 68, 95, 99.7 rule. 68% of data falls within one standard deviation of the mean. 95% falls within second standard deviation, two standard deviation. 99.7 falls within three standard deviations. Here's the diagram for better representation. Here is a summary table for you which statistics to use. If your goal is to find the typical value, use mean or median. Check how consistent data is, standard deviation, if two variables move together, correlation, Pearson's, or t-test, etc. Compare two values, t-test, compare 3 plus groups, example section ABC, ANOVA. If your goal is to predict a future outcome, regression. Tip for you guys. If a question asks you why you choose a specific statistic, your answer should always mention two things: type of data, categorical versus numerical, the research objective, describe, compare, or predict. Next topic, choosing the appropriate statistics. Following the completion of the stages of data organization, visualization, description, summarizing, the researcher starts with determining which statistical techniques are suitable for subsequent analysis. Neither convenience nor preference had the role in the making of the selection. Was not made at random. As an alternative, it is determined by the characters in the data itself. In the same way, the carpenter would choose not to use hammer to cut the wood. A researcher needs to choose statistical methods that are comparable with the kind of data that is being studied. Regardless of how complex the study appears to be, the use of improper statistical methods might lead to conclusions that are deceptive. Before selecting a statistical approach, the researcher is required to apply to a number of fundamental questions, including the following. Are we working with a single group or are we comparing numbers of different groups? Whether the variables are continuous or discrete is relevant. The most important question regarding the data is what scale of measurement does it represent? Next topic, continuous and discrete variables. The variables can be broadly classified into continuous and discrete types. Continuous variables. These can take on infinite values within a given range. Example, height, weight, time, temperature, etc. Discrete variables. These will consist of distinct countable values. Example, number of children, grade level, number of absences. While distinction is important, it is not sufficient for selective appropriate statistics. The more decision factor is the scale of measurement. The next topic, the four scales of measurement. The concept of measurement was formalized by psychologist S. Stevens. Remains one of the most important frameworks in quantitative research. Every quantitative values, every quantitative variable falls under one of these four categories: nominal, ordinal, interval, ratio. Each scale determines what mathematical operations are permissible, which descriptive statistics are meaningful, which inferential tests are valid. Here's a table for you guys. Go through them while reading the notes. Nominal scale, the naming scale. The nominal scale is the simplest form of measure. Numbers are purely as labeled as to classify each case into category. These numbers carry no quantitative meaning. Example: single equals to 1, married equals to 2, divorced equals to 3, widow equals to 4. Assigning education level as high school 1, undergraduate as 2, postgraduate 3, and representing modes of car as 1, 2, bus 2, train 3, bus 3. Importantly, these numerical codes are purely arbitrary and serve only as labels. Changing the numbers assigned to each category would not affect the meaning interpretation of data. What you can and cannot do with nominal data. You can count frequencies. You can identify mode. You cannot add, subtract, multiply, or divide. You cannot calculate means or standard deviation. For example, it makes no sense to say category 2 is twice as many as category 1. After statistic frequencies, percentage modes, chi-square test. Next topic, ordinal scale, ranking scale. The ordinal scale introduces order. Values indicate rank or position, but the distance between ranks is unknown or unequal. Example, class rank. Here are three students, Lewis, Jenny, and Marietta. And here they're given GPA 4, 3.9, 3, and here's the ranking 1 to 3. We know Lewis rank above Jenny, and Jenny ranks above Marietta. However, the difference between ranks is uneven. Difference between rank 1 and 2 is zero point 0.1 GPA. Difference between rank 2 and 3 is zero point 0.9 GPA. The other examples are like heart scale response, strongly agree to strongly disagree to strongly agree. Pain, severity rating, percentile ranks, example 90th percentile. Appropriate statistics use, median percentiles, rank based test, example man with you. Arithmetic means are generally discouraged because ordinal scales lack equal intervals. Interval scale, equal units without a true zero. The interval scale introduces equal space between values. A difference of 10 units means the same everywhere on the scale. However, interval scale lacks a true zero point. Zero does not represent the absence of quantity being measured. Examples: temperature Celsius or Fahrenheit, difference between 30 and 40 equals difference between 70 and 80. Zero degree does not mean no temperature. IQ scores, equal differences are meaningful, and IQ of zero does not imply absence of intelligence. Appropriate statistics, example mean, standard deviation, correlation, t-test, and ANOVA is distribution as a business format. However, ratios are meaningless. It is incorrect to say that 80 degree Fahrenheit is twice as hot as 40 degree Fahrenheit. The ratio scale, the ultimate scale. The ratio scale encompasses all the characteristics of interval data and incorporates a genuine zero point, signifying the total absence of the measured quantity. Examples: height, 0 centimeter means no height. Weight, 0 kg means no weight. Income, 0 rupees means no income. Time duration. Because zero is meaningful, ratios are interpretable. Analytic power of ratio data. With ratio data, researchers can add, subtract, multiply, or divide. Statements such as group A turn twice as group B are valid only within ratio scale data. Why scale identification is crucial. The scale of measurement determines which statistics are valid, which conclusions are meaningful, which analyses are mathematically defensible. For example, applying a mean to nominal data is meaningful. Applying a parameter test to ordinal data violates assumptions. Treating skewed ratio data as normal leads to distortion. Crucially, scale judge must be made at the data collection stage. Once data is collected at nominal, example pass/fail, it cannot later be converted into ratio data. Example scale. Inferential statistics. While descriptive statistics describe what is your specific goal, inferential allows you to make educated guesses about a larger group, the population, based on the sample. It is the bridge between a small experiment and universal truth. The logic of inference, because it is generally impossible or too expensive to study every single person in population. Example, every farmer in India. Researchers take a representative sample. Inferential statistics use laws of the probability to determine how likely it is the result from the same sample applied to whole population. Estimating population parameters. This involves using a sample statistic like a sample mean to ensure the true value in the population. Point estimation. A single value. Example, the average height is 170 centimeters. Interval estimate confidence intervals. A range of values within which the true population parameter is likely to fall. Example, we are 95% confident that the average height is between 168 centimeter and 172 centimeter. Here is the diagram, my representation of what I said earlier. Next topic, hypothesis testing, the trial of research. Hypothesis testing is a systematic way of deciding if a result is real or just lucky fluke. The two hypotheses, the null hypothesis and alternative hypothesis. The innocent until proven guilty stance, it assumes that there is no effect, no difference, no relation. Example, the new medicine does not work better than a sugar pill. Alternative hypothesis, the researchers claim it assumes there is a significant effect. Example, the new medicine significantly improves recovery time. The p-value, the probability of chance. The p-value is the probability that the observed research occurred by pure random chance. If p is less than zero point zero 0.05, the result is statistically significant. We reject the null hypothesis. There is less than 5% chance the result was a fluke. If p is more than 0.05, the result is not significant. We fail to reject the null hypothesis. The common differential test. Test name: one sample t-test. When it is used to compare a sample mean against a known value. For example, if the average IQ of this class is higher than the national average 100. Independent t-test. It is used to compare the means of two different groups. Example, does group A boys score higher than the group B girls? Pair t-test. It is used to compare the means of the same group at the two different times. Example, measuring student anxiety before and after medication session. ANOVA, analysis of variance. It is used to compare the means of three or more groups. Example, do students in section A, section B, and section C have different average scores? Next up, errors and inference. In the exam, you may be asked about how researchers get it wrong. Type 1 error, false positive. Rejecting the null hypothesis when it was actually true. Finding an effect that isn't there. Type 2 error, false negative. Failing to reject the null hypothesis when there was actually an effect. Missing a real discovery. Based on the case study we discussed earlier, it's the extension of that case study. Do watch the earlier videos for the case study. Dr. Anna inference. Recall Dr. Anna and her study on learn fast notification. Descriptive step. She found the mean anxiety score was 75/100 for the notification inferential set. She ran an independent t-test comparing students with notifications versus students without. Result. Her p-value was 0.02. Conclusion. Since 0.02 is less than 0.05, Dr. Anna rejected the null hypothesis. She can now state with confidence that the notifications do associate with higher anxiety in the wider 10th age population. The case study, Learn Fast and Society, let's discuss it again in detail. Researcher named Anna Kumari. The core problem. Anna wants to know if the frequent nudge notifications sent by the Learn Fast education app are causing higher anxiety levels in 10th grade students. The researcher says the starting point. Before Anna can make any big claim, she must look at her specific sample of 100 students. The data, she measured the anxiety on scale 1 to 100. The mean, she calculates that the average mean anxiety score for students using the app is 75. The limitation, this 75 is just a number. It doesn't tell her if this is high by chance, or if it represents all 10th grade in the country. Setting up the inferential test. Anna moves into section 3.5 logic by setting a formal trial for her data. The null hypothesis. This the app notifications have no effect on anxiety. Any difference we see is just a random fluke. The alternative hypothesis. The app notifications are significantly associated with high level anxiety levels. Here the diagram, here the demographic representations of the data. You can see the null hypothesis and an alternative hypothesis. Here are the results. Choosing the choosing the tool. The independent teacher. Anna decides to compare two groups. Group A, students receiving notification. Group B, students with notifications turned off, the control group. Why this two? Because she's comparing the means of exactly two groups to see if the difference between them is mathematically significant. The moment of truth, the p-value. After running her data through the statistical program, Anna gets a result of point, as we discussed earlier. The interpretation, since point 0.02 is less than 0.05, the standard university threshold, she has enough evidence to reject the null hypothesis. The verdict, there is only 2% chance that the difference happens by accident. Therefore, the result is statistically significant. Generalization. Because her inferential test step was successful, Anna can now move from her small sample of 100 students to a generalization. Based on this study, we can infer that the constant notifications are likely increasing anxiety among the wider population of 10th grade students using the Learn Fast app. Summary. Why this case study is included? Purpose. It demonstrates that the research isn't just about averages, descriptive. It's about probability and proof inferential. The significance of zero point zero 0.05. The case study highlights that zero point zero 0.05 is a magic number in research. Anything below it allows the researcher to claim their findings are real, actionable insight. Because of this statistical inference, and I can now recommend that the app developers change their notification frequency to protect students' mental health. Summary, key distinction, description tab equals to summary, inferential equals to prediction. Golden rule. The value of 0.05 is the standard cutoff for significance. The goal to generalize findings from small sample to a large population. Next topic, descriptive statistics, measures of central tendency. These central tendency identifies the center or most typical values of data set. Mean, median, mean. The arithmetic average, it is the most common value but is highly sensitive to outliers. Extreme values, median. The exact middle value when data is ranked. It is robust against outliers and is preferred for ordinal scales or skew data like income. Both the most frequent value is data sheet. This is the only measure applicable to nominal categorical data. Next topic, descriptive statistics measures of variability. Range, variability describes how spread out the data is around at the center. It is divided into range, standard deviation, normal distribution. Welcome. Range, the difference between maximum and minimum values. Standard deviation, the average distance of each data point from the mean. Low SD indicates highly consistent performance data. High SD indicates highly erratic and hours data. Normal distribution, the bell curve. In a normal curve, approximately 16% of the scores fall within +1 -1 HD. 95% falls within +1 plus or minus 2 SD and 99.7 within ±3 SD. Measures of association correlation. Correlation determines the relationship between the two variables and strength of the relation. Pearson Coefficient of determination, critical. Pearson's are coefficient range from -1 to +1. Positive correlation, both variables increase student example. Study hours and grades. Negative correlation, as one variable increases, the other decreases. Example, the number of friends and the likelihood of being bullied. Coefficient of determination, R square, represents the percentage of variance in one variable explained by the other. Critical rule. Correlation does not equal causation. Next topic, interpreting results, conclusions, and recommendations. Interpreting the data, discussion session. Interpretation is the sense making process that moves beyond raw numbers to explain their implication. Objective, presentation. In quantitative reports, results should first be presented objectively, often using table figures, before being interpreted. Answering research questions. The primary goal is to excellently state what the data means in relation to the initial research problem. Cautious language. Avoid words like proof. Instead, use phrases like finding are consistent with hypothesis or result support because the inferential statistics are probabilistic. Handling mismatch results. If data contradicts prediction, researcher must examine weaknesses. Example, low statistical power, instrument validity, and report them candidly. Drawing conclusions. Conclusions provide a telescopic view of the study impacts. Summarizing findings, reiterate the main results and address the so what question regarding their importance. Connecting to the theory. Relate the findings back to the existing literature or the state of the art identified earlier. Identifying limitations. Be transparent about the weaknesses, bias, or delimitations, what are intentionally not studied and might impact the study's validity. Making recommendations. Recommendations turn research findings into actionable insight. Practical recommendations suggest actions for professionals in the field. Example, developers, teachers, or policymakers based on the evidence. Future research context. Proposing new questions or alternative explanations that other researchers should test in the future. Here the summary table. The analytics to conclusion flow. Phase analysis. Key activity. Calculate mean, SD, correlation. Uses tables for precise numbers and figures for trends. Insights. Calculate p-value. If p-value is less than 0.05, the result is statistically significant. Interpretation. Explain the why. Never assume the correlation proves causation. Conclusion. Summarize the so. Don't go beyond what your data actually supports. Recommendation. Suggest next step. Link these directly back to your findings. Next topic. Inferential statistics. Moving from sample to population. While descriptive statistics summarize a specific group, the inferential statistics provide tools to draw conclusions about a much larger group, the population, based on small samples known as sample. We have discussed the case study earlier about this topic, so I won't go around this again. Population sample, notation difference, sample versus mean population, standard deviation. Uh, Next topic, the logic of estimation and sample error. Sampling error. Different samples from same population will yield slightly different means due to random variation. Sampling distribution of the mean. If you plotted the means of 1,000 different samples, the result distribution would be approximately normal bell shape, centered at the true population. Standard error of the mean. This qualifies of how much variability to expect to the sample. Crucial example. A sample size n increases, the standard error decreases, leading to more precise estimation of the population. Point versus interval estimates. Point estimates. A single number guess for the population value. Example, the average is 0.712 centimeter. These are almost always slightly inaccurate due to sampling error. Interval estimates. Confidence intervals. A range of possible values. Example, we are 95% confident. The true average lies between 0.708 centimeter and 0.713 centimeter. Interpretation. If you drew many samples, compute a 95% confidence interval for each. 90% of those intervals would contain the true population. Next topic, the inferential statistics, the logic of hypothesis testing. Hypothesis testing is a formal technique used to determine if an observed result is a genuine effect or merely the result of random chance. The logic code, the null versus alternate hypothesis. The researchers do not try to prove their idea directly. Instead, they try to disprove the possibility nothing happens. The hypothesis, the result assumption that there is no effect, no difference. We have discussed this analogy. In a court of law, the defendant is innocent until guilty proven as is the assumption of innocence, no effect. Alternative hypothesis, the original actual claim that the effect does not exist. Decision process and p-values, we have discussed this earlier. The potential errors in judgment, we have discussed these also. We have discussed the common statistical test, t-test, two types, compare the minds of two groups, and ANOVA test compares three or more groups. The key square is a new. Used for categorical data example, there is a link between gender and passing training exam, the big picture tips, descriptive answers, where is my data, immediately, inferential answers for inferential search, what does my data mean for the bigger picture, p values, hypothesis, golden rule. The significant research p less than 0.05 does not mean the effect is large. It only means that the effect is unlikely to be fluke. Here is a quiz for you guys. I've already marked the answers, so if you want, you can go through them. Which scale of measure uses categories that have no inherent numerical values or order? Example, eye color, country of birth, nominal. Which measure of central tendency is most appropriate for a skew distribution because it has not been by extreme outliers median? The empirical rule for normal distribution shared that about 95% of the population falls within two standard deviations of the mean. If a, if a researcher rejects a null hypothesis, one, it is actually true, they have committed a type 1 error, the square root of which statistic gives you the standard deviation, the variance. The p-value of 0.03 means the probability of result occurred by chances 3 out of 100 in a scatter plot. If the points cluster tightly around a line that rises from left to right, it indicates a strong positive correlation. The standard error of the mean decreases as the sample size and increases. A leptocritic distribution is one that is too pointy, cluster tightly. The statement correlation does not imply causation means. Just because two variables move together does not mean one causes the other. With this, we are over with Unit 3. If you guys like my video, subscribe to my channel and share it with your friends. Uh, we'll be back with Unit 4 soon. Till then, bye. And also, I want you guys to share this video. I need subscribers, man. I need more subscribers. So bye. See you guys on the next video. Bye. Yo everyone, how are you all? Today I'm going to start with the Unit 4 of the course Research Methodology. So without wasting any further time, let's get started. Unit 4, Presenting Research Outcomes. Learning objectives. After studying this unit, students will be able to clearly explain and justify a research problem to a specific audience, describe the methodology and data in enough detail to allow for replication by other researchers, present and interpret data accurately without overclaiming results, identify the inherent weakness, limitations, and boundaries, delimitations of a study, draw logical conclusions, and provide actionable recommendations based on the findings. Explanation of research problem. The introductory section of research report is critical as it establishes a confrontation of mind between the writer and the reader. Purpose of the problem statement. Comprehension, context, justification. Comprehension. Readers must be able to understand exactly what the problem is and what its consequences are simply by reading the report. Context. The report should describe the environment in which the problem was created so the reader appreciates its significance. Justification. The author must explicitly state why the research was significant to carry out from both academic and practical perspectives. Structuring the introduction. Clarity and precision. Authors often fail by not presenting the problem distinctly, which creates a misty veil that obscures the rest of the report. The funnel approach. Start with preliminary remarks, a few lines or paragraphs, covering the general background before moving to explicit issues. Research. Use subheadings. Effectively, subheadings can be used to attract readers' attention to the specific research problem. Defining key terms. Shared understanding. Ambiguous or technical terms must be defined clearly to avoid confusion. Operational definition. Terms should be defined by how they are measured in the study. Example, defining low light condition as any image with an average pixel intensity below 50 on an 0 to 25 RGB scale. Example, defining accuracy as the F1 score, a metric balance, precision and recall, rather than simple accuracy, explaining why it is better for high risk security tasks. Subproblems and hypotheses. Breaking down the problem, the main research problem is often divided into smaller manageable subproblems. Testable hypothesis. The researcher should state specific testable predictions that the study aims to investigate. Exam summary. The goal. By the end of the introduction, a reader, such as a fellow computer scientist, should exact know exactly what you set out to achieve and why it matters to the community. Transparency. Remember that readers only know what is written on the paper. Assumptions about their prior knowledge of your specific problem can lead to poor start. Next topic, describing the research process and data. This section, often titled Methodology, is operational heart of the report. Its primary objective is to provide a reproductive roadmap of how the study was conducted. Core components of the method section. To ensure academic rigor, the description must be so precise that another researcher could repeat the study and achieve similar results. Subjects/participants clearly describe who and what was studied. Example, in a computer science study, this might be a specific dataset like 10,000 low light images from a COCO dataset. Procedures outlining the step-by-step actions taken during the research. Example, detail the specific training parameters such as the model was trained for 50 seconds with the learning rate of 0.001. Instructions and metrics. Define the tools used to measure outcomes. Example, performance metrics like F1 score, latency, average interference time, and parameter code accessibility. If custom code was developed, its location, example, GitHub responsibility should be mentioned to allow for verification. Next topic, presenting the data and data analysis. The results section is where you lay out the evidence gathered from a methodology. In quantitative research, this section should remain objective and uninterrupted, simply letting the data speak. Organizing the results. Logic driven structure. Findings should be organized around the original subproblem or hypothesis to ensure the report directly addresses the research question. Rationale for analysis. You must explain why a specific statistical test was chosen. Example, a two sample t test were performed to determine if the difference in scores was statistically meaningful or not due to chance. Visualizing data. Next topic, visualizing data, tables versus figures. Raw data should be synthesized into concise, digestible format, like tables, figures, labeling. Tables, best for displaying precise numerical values or compact text. Figures, best for illustrating trends and patterns and visual summaries. Example, bar charts, flow charts, or photos. Labeling rule, every table and figure must be numbered, captioned, and referred directly in the text. Example as shown in table. Next topic, reporting reliability and unexpected findings. Reliability. Always report the internal consistency of instruments. Example, Cronbach's alpha and iterator reliability if multiple people quoted the data. Unexpected data. Do not hide findings that contradict your hypothesis or were unexpected. Example, reporting that an algorithm was more accurate but significantly slower than a baseline, even if speed wasn't the primary focus. Exam summary, comparing quantitative and qualitative presentations. Here are the features, then quantitative report and qualitative report. Writing style, objective, scientific, neutral. Qualitative report, narrative, personal, and interpretive. And for the primary data, the quantitative reports are numbers, statistics, and tables. And for qualitative report, participants, quotas, dialogues, metaphors. And the main focus of qualitative report is statistical significance and hypothesis testing. And the main focus of qualitative report is mean making and thematic depth. Here's another tip for you guys. A result section that includes raw unorganized data is considered poor quality. Always synthesize data into clear summaries and place large raw databases in appendix. Next topic, insight and explanation, interpreting the data. Interpretation is a process of moving beyond the raw facts of the results to explain their intrinsic meaning. A report that presents data without interpretation is considered incomplete. The core task, making sense of evidence. Resolving the research problem. The researcher must explicitly state what the findings mean for the initial research question. Example, a significant increase in performance score, example, F1 score, should be used to confirm or refute the original hypothesis. Connecting to theory. Findings should be discussed in a context of existing literature. Do they support current theories or suggest new ones? Guidelines for ethical interpretation. Avoid overclaiming, correlation versus causation. Use cautious language. Let's discuss them one by one. Avoid overclaimage. Researchers must not go beyond what the evidence supports. Beginners often let personal beliefs influence conclusions. Example, claiming effects on a group like children without having collected data from them. Correlation versus causation. Never treat correlation as proof of causation. Avoid using strong casual words like lead to or influence unless the research design strictly justifies it. Use cautious language. Before inferential statistics are problematic and can be wrong due to chance. Use hedging terms such as the results support, findings are consistent with, avoid the results prove. Next topic, handling mismatched results. If results do not match predictions, do not hide them. Instead, examine weakness. Check for issues like low statistical power, instrument reliability, or type 2 errors. Accept negative results. Be willing to admit the hypothesis may be wrong. Propose alternatives. Suggest different explanations for further testing. Next topic, research integrity. Identifying possible weakness. Every study has its flaws. Professional research requires honesty about these weaknesses to maintain academic dignity. Integrity, sorry. Integrity. Next subtopic, limitations versus delimitation. Limitations. Let's discuss limitations first. These are constraints beyond the researcher's control that may have influenced the findings. Example, a small sample size or specific network condition that might change results if altered. Delimitation. These are the boundaries set by the researcher, what the study intentionally did not intend to cover. Example, choosing to study only live video conferencing rather than all types of video streaming. Next subtopic, assumptions and biases. Assumptions. Self-evident truths or conditions the researcher takes for granted. Example, assuming participants answered the survey truthfully. Biases. Personal prejudices or systematic errors that might have affected data gathering or interpretation. Integrity requires disclosing these so readers can judge the study's validity for themselves. Next subtopic, key indicators of quality. Truthfulness, being perfectly open about what was actually accomplished versus what was intended. Candid reporting, reporting flaws even when they are contradicting to your prior expectations. Here is a summary on interpretation and integrity. Features and role in report, an example. Interpretation. Role in report of interpretation explains the so what of the data. Always link findings back to the original subproblem. Limitation. Warns the reader of study weaknesses. Help other decide how much to trust the findings. Integrity. Ensures the research is credible. Report unexpected or counter hypothesis data honestly. Language. Maintain scientific neutrality. Use support instead of proof. Next topic. Conclusion and future context. Summarizing and extending. The final section of research report serves as a telescopic view that moves from specific findings of the study to their broader significance in the real world. Summarizing findings. Directly answer to the problem. Synthesis, not repetition. Example. Let's discuss them one by one. Direct answer to the problem. The conclusion must explicitly state the final verdict on the research problem or hypothesis. Synthesis, not repetition. Do not simply repeat the results. Instead, synthesize them to show how they resolve the initial inquiry. Example. For a student on video streaming, our conclusion might state for live video conferencing, UPD is preferred over protocol due to its low latency, prioritizing speed over absolute data integrity. Next subtopic, putting findings into context. Theoretical implications. Discuss how the findings relate to existing theories in the field. Do they support current beliefs or challenge them? Practical context. Explain how these findings can be used to improve future policies, professional practices, or technological designs. Next subtopic, future research and extension. Addressing limitations based on the weakness identified in the study. Suggest what should be done differently next time. The next step, identify new questions that arose during the studies that warrant further investigation. Example, future research should investigate the performance of custom application layer protocols built on the top of UDP to handle error correction for more efficiently than standard TCP. Summary, next topic, summary of the presenting research outcomes. This section summarizes the six essential elements of high quality research report. The six core objectives of our report are: a professional research report is an official document and a persuasive argument for contribution to its knowledge, and it must explain the problem, describe procedures, present full data, interpret the data, identify weakness, summarize, and contextualize. Let's go through them one by one. Explain the problem, provide a clear idea of the research issue, and justify why it deserves investigation. Describe procedures. Outline the precise mechanisms, methodology used so the study is reproducible by others. Present full data. Report information accurately and fully using tables and figures. Interpret the data. Explain what the facts show and how they resolve the any research problem. Identify weaknesses. Warn readers of potential limitations, constraints, and assumptions and biases. Summarize and contextualize, and the summary that relates findings to existing theories and future practices. Next subtopic, key characteristics of quality reporting. The key quality characteristics of quality reporting are academic integrity, objectivity, formatting, and citation. Academic integrity requires perfect truthfulness, source crediting, and full disclosure of results, including those that contradict expectations. Objectivity. The report should not aim to prove a point, but rather to support findings based on evidence. Formatting and citations. Adhering to specific styles like APA, MLA, or Chicago for reference lists ensure that work is credible and verifiable. Here's another summary table for you guys. Report sections and their objectives. Let's go through one by one. Introduction. Its primary objective is to state and justify the research problem. Methods describe the procedures in enough detail for replication. Results presenting data objectively using tables and figures. Discussion explain the so what and interpret the evidence, the weaknesses. Disclose the limitations and researcher biases. Conclusion summarize findings and suggest future direction. Here is the quiz for you guys. The main purpose of I have already solved this. Let's go through them as a revision. The main purpose of the introduction section is to state and justify the research problem. In a well structured method section, the description should be detailed enough so the readers can replicate the study. In a qualitative research report, the results section should primarily present data objectively, often with tables and figures. Which of the following is true about data interpretation? Conclusions must not go beyond what the data support. Delimitation is in a study refers to what the researcher never intended to study. A reference list at the end of the report should include only sources cited in the text. In an APA style, the journal title in a reference entry is written in italics and in title cases. Which statement is most appropriate for cautious interpretation? The findings are consistent with the hypothesis that X affects Y. A figure in a research report may be any graphic such as graph, chart, map, or diagram. What characterizes academic integrity in reporting? Full results, disclosure, source crediting, and being perfectly truthful about what was accomplished. With this, Unit 4 is over. I will make another video about Unit 5 soon. Uh, anyway, if you like this video, share with your friends and subscribe to my channel. See you guys soon. Bye. Yo, what's up, guys? Welcome back to Learn with Endless. Today I'm going to start with the Unit 5 publication of the course Research Methodology. If you guys haven't watched the earlier units, I do recommend to go through them. I have posted the 4 units plus one syllabus video, so go watch them for better understanding. So, without any wasting any further time, let's get started. Unify publication, learning objective. After completing this lesson, students will be able to understand the basic concepts and multi-step process of academic research publication, formulate research problems and objectively systematically for publication, apply appropriate methods for data collection, structure analysis suitable for professional discipline. Let's start with the topic, Introduction to Publication. In a world of academia, research is considered a half-baked idea until it is formally communicated to the world through a journal, conference proceedings, or a book. The purpose of academic publication, because backbone of progress, it transforms verification, career catalyst. Let's go through them one by one. Backbone of progress. It transforms individual findings into a collective verified body of knowledge. Verification. A publication is a well-structured document that has been poked by experts to ensure the results are genuine and trustworthy. Career catalyst. Mastering this process is a vital skill that links classroom learning to professional research career. Next topic, common publication outlets. Research choose formats based on their project scope and intended audience. Here's the table. Outlet type, key characteristics and suitable for UG research. Outlet type, peer-reviewed journals. Its key characteristics are rigorous review, permanent scholarly record. It is suitable for UG researchers for high impact and finished projects. Outlet type, conference proceedings. Its key characteristics is faster publication, ideal for networking. It's suitable for preliminary or early stage findings. Outlet type UGC care journals. Its key characteristics are nationally recognized and accessible in India. It's ideal for standard college level professors. Repositories, example, Shodhganga, Shodhganga. Its key characteristics are immediate sharing, provides DOIs. It's suitable best for sharing datasets and preprints. Student journals, these are focused on learning and supportive review progress, and it is recommended for first-time publication. Next topic, process of journal submission. The submission process is a multi-step journey that requires careful technical and ethical preparation. Phase 1, selecting the right journal. This includes scope check, audience, and guidelines. Scope check. Authors must pick a journal whose themes matches their research area. Audience. Determine if the journal is national, international, journalist, or specialist. Guidelines. Every journal has instructions for authors, author guidelines that act as a formula for the manuscript. Failure to comply with these is leading cause of instant rejection. Phase 2. Preparing the manuscript. A standard research paper follows a structured anatomy, and these include front matter, introduction, materials and methods, results, discussion, and references. Let's do them one by one. Front matter, titles, authors, concise abstracts, and keywords. Introduction sets the stage for the research project. Materials and method, detailed enough to allow for replication. Results, clear presentation using text, tables, and images. Discussion, blending findings with previous research and admitting limitations. References, a complete list of cited works formatted exactly to the journal's chosen style. Example AP. Phase 3. Final checks and submission. Before clicking submit, responsible authors must perform two critical checks: proofreading, ethical approval, and plagiarism check. Proofreading. Ensure that writing is logical, data is accurate, and permission for images and questionnaires are secure. Ethical approvals. Verify that approvals from the Institutional Review Board, IRBs, or ethical committees are granted and mentioned, especially for studies involving humans or animals. Plagiarism check. Many journals use specialized software to ensure the work is original before it proceeds to review. Here is the publication life cycle flowchart. Preparation, formatting, submission, editorial screening, peer review, publication. Let's go through them one by one. Preparation. Finalize research and select a target journal. Formatting. Align the manuscript with specific author guidelines. Submission. Upload the manuscript and ethical clearance document. Editorial suite. The editor checks for scope fit and plagiarism. Peer review. Experts evaluate quality, leads to accept, revise, or reject. Publication. The final proofing and release to the academic community. Here's a important tip for you guys. Always emphasize that a journal's instructions for authors is the most important document for a researcher during the submission phase. Ignoring these instructions often result in discreditation. Uh, Next subtopic, where to publish, selecting the right platform. Selecting a suitable venue is critical for ensuring your research reaches the intended audience and carries academic primary academic outlets, academic journal, primary academic outlets, and these are academic journals, conferences, seminars, and workshops. Academic journals, the gold standard for research. They use peer review to ensure quality and can be national or international, and open access or subscription based. Conferences, seminars, and workshops. Ideal for sharing early stage ideas, practical applications, networking. Findings are often published in conference proceedings. B. Journal models. There are two, open access and subscription. Open access. These articles are freely available or accessible to everyone with internet connection, and for the cost usually involves a one-time fee paid by the author or their institution. Next, subscriptions. Access is restricted to an individual or institutional subscribers like libraries, and for the cost generally free for authors to publish. In. Next subtopic, avoiding predatory journals. Predatory journals are fake outlets that charge fees without providing genuine peer review. Warning signs, promises of lightning fast publication, sloppy website design, and lack of clear information, unverified or unknown editorial board members, unverifiable claims about high impact factors. Next subtopic, peer review process. Next topic, peer review process. Peer review is the backbone of quality control. In academic publishing, it is a system where experts in the same field evaluate a manuscript before it is published. Purposes of peer review: quality assurance, improvement, gatekeeping. Let's go with first one. Quality assurance evaluates validity, reliability, and study designed to prevent flawed claims from entering literature. Improvement provides feedback to enhance clarity, structure, and finding. Gatekeeping helps editors decide which original and methodologically sound works deserve limited publication space. Next subtopic, common peer review system. And these are single blind, double blind, open peer reviews. Let's go through them one by one. Single blind, reviewers know the identity of authors, but authors do not know who the reviewers are. Double blind, neither the authors nor the reviewers know each other's identity, which helps reduce bias. Open peer review, both parties knew each other's identities. Reviews may be made public. Next subtopic, the review lifecycle flowchart. Submission, discretion optional, external review, editorial decision. Let's go through them one by one. Submission. Author sends manuscript to the journal. Discretion optional. It may or may not happen. Editors reject the paper immediately if it lacks basic quality or doesn't fit the journal scope. External review. Experts evaluate the work and send feedback to the editor. Editorial decision. The editor chooses one of the four options: accept, minor revision, major revision, or reject. Next topic, scientometrics, measuring research output. Scientometrics is a quantitative study of scientific literature to measure the impact and influence of researchers, journals, and institutions. Journal level metrics, journal level factor, JIF, are a numerical indicator of the average number of citations per article in a journal. Next, author level metrics. These include H index, G index, and I10 index. H index, an author has an index of H if they have published H papers, number of papers, with an index. uh, that have each been cited at least n times. Example, an n index of 10 means 10 papers at least have 10 citations each. G index gives more weight to the author, mostly highly cited paper. I'm citations primarily used by Google scholars counts how many authors' works have at least 10 citations. Comparison of next topic comparison of author metrics. Matrix type, H index, its main focus is quantity plus quality. Key strength balances number of papers with their impact. G index, peak impact, highlights the influence of author's best work. Identity, its main focus is on frequency. Simply to understand and widely used on Google Scholar profiles. Important tip for guys. The 10% rule. In India, UGC generally allows a maximum of 10% similarity in plagiarism checks. Exceeding that can lead to penalty ranging from warnings to degree cancellation. Check the instructions before submitting any paper. Always download your journal's instructions for authors to avoid instant rejections for formatting errors, hedging. When discussing results in your exam, use phrases like the findings support rather than the findings prove, as statistics are probabilistic, not absolute. Next topic plagiarism and plagiarism checks. Plagiarism is defined as unethical practice of using someone else's ideas, works, data, or creative work and presenting them as one's own without proper acknowledgement. It is a serious violation of academic integrity and intellectual honesty. Uh, Next subtopic common forms of plagiarism. Plagiarism can occur intentionally or unintentionally, and these can be verbatism, direct plagiarism, mosaic plagiarism, patch writing, paraphrasing without acknowledgement, self plagiarism, accidental plagiarism. Let's go to them one by one. Uh, Verbatim or direct plagiarism, copying exact sentences or paragraphs word for word from a source without quotation marks and citation. Mosaic plagiarism, taking phrases from different sources and rearranging them into original text, maintaining much of the original structure without citation. Paraphrasing without acknowledgement, expressing someone else's ideas in your own words but failing to credit the original author. Self plagiarism, reusing one's own previously published work, such as earlier articles or theses, in a new publication without disclosure. Accidental plagiarism, occur, occurring due to incorrect citations, poor note taking, or lack of awareness regarding referencing rules. Consequences. Next subtopic: consequences of plagiarism. Detecting plagiarism can lead to severe penalties for students and researchers, and these penalties include academic penalties, institutional actions, or professional damage. Academic penalty: rejection of manuscripts. These include rejection of manuscripts, loss of academic credit, or failure in courses. Institutional actions. These include disciplinary measures from universities, including suspension or even cancellation of a degree. Professional damage or retraction of published articles and long-term damage to researchers' reputation. Next subtopic, plagiarism checkers. Plagiarism detection tools or softwares used by academic institutions and publishers to promote integrity. How they work? These tools compare our submitted text against massive databases of existing publications and websites to find similarity. Similarity index. In India, the UGC plagiarism regulation 2018 specify allowable similarity percentages and corresponding punishments for students and faculty. Here is a summary for the publication. These include roadmap for this unit, preparation, roadmap for publication, preparation, second compliance, third submission, then verification, quality control, and impact measure. Let's go through one by one. Again, preparation, selecting our target journal based on its scope and pursuing recent issues. Compliance, following the detailed instructions for authors regarding structure, formatting, and ethical statements. Submission, ensuring the manuscripts include a clear title, abstract keywords, methodology for replication, results, and discussion. Verification, performing the final checks for logical flow, data accuracy, and secured permission for image or questioning. Quality control, undergoing the peer review process, single blind or double blind to ensure scientific quality. Impact measurement, using scientometrics like H-index or journal impact factor to evaluate the influence of the work and the journal. Here is the table for better understanding. and easier to write an exam. State submission. Goal is format alignment. Key to author guidelines. Integrity check. Main goal originality verification. Key to plagiarism check. Review. Main goal expert evaluation. And key to peer review. Impact. Main goal major reach. And matrix scientific indicators. Uh, Important tip for guys, the golden rule for citation. Even if you change the wordings, paraphrase, the underlying idea still belongs to someone else and must be cited. Check the bibliography. Your reference section must be complete list of only the works actually cited in your paper. Standard structure. I am ready. Remember the core components. Introduction, materials and methods, results and discussion. Here is a quick quiz for you guys. I have already solved it. So just take it as a review or an revision. The IMRD structure of a research paper stands for Introduction, Methods, Research, and Discussion. Here is an explanation for you guys. This is a standard structure format for most scientific and academic research papers. It ensures a logical flow from the research problem, introduction to how it was studied, methods, and what was found results, and what it means, discussion. Which of the following is the primary reason for discussion of a manuscript? The manuscript is outside the journal scope or fails basic format. And here's the explanation. A disquisition occurs when the editor decides not to send the paper for peer review because it doesn't fit the journal's focus area or violates fundamental submission guidelines. In a double-blind peer review process, neither the author nor the reviewers know each other's identity. An explanation. This system is designed to reduce biases. Reviewers cannot be influenced by the author's reputation or institution, and authors cannot target specific reviewers for their feedback. What is the standard threshold for similarity plagiarism allowed by UGC in India for students? It's less than 10%. According to UGC regulation, a similarity index of less than 10% is generally acceptable. Higher percentage can lead to penalties ranging from manuscript revision to the cancellation of a degree. The journal impact factor, GIF, is a measure of the average number of citations received per article in that journal. Explanation. Scientometrics uses GIF to estimate the prestige and influence of a journal within its field base and on how frequently its published work is cited by others. If a researcher reuses significant portions of their own previously work without citation, it is called self-plagiarism. Explanation. Even though the work is their own, once it is published, it becomes part of the formal record. Using it again without acknowledgement is considered an ethical violation known as self-plagiarism. SJR, SCLMLO journal rank, is a matrix that accounts for both the number of citations and the prestige of the journals where they come from. SJR is a prestige weighted matrix. A citation from a high impact journal like Nature or the Lancet is given more weighted than the citation from a lesser known publication. Which metric measures an author's impact by balancing the number of papers and their citations? The H index. Explanation. An H index of H means the author has published H number of papers and each have been cited at least n number of times. It rewards both productivity and consistency. Open access (OA) journals are characterized by making articles free available to all readers, often via author fees (APC). Explanation. Open access is designed to remove barriers to knowledge, allowing anyone with internet access to read the research for free, shifting the cost from reader to the author or their institution. An H index of 10 means the author has at least 10 papers, each of which have been cited at least 10 times. The matrix ensures that the author's impact is spread across multiple works rather than just one lucky, highly cited paper. Here is an exam summary flowchart again. Select journal, submission, review, integrity, impact. We have go through this. Select journal based on the scope, matrix, yes, or indexing. Scopus, UGC here. Submission, follow instruction from instruction for mandate to award. Destination, review, peer review, single or double blind. Provides the decision, accept, revise, reject. Integrity, use president checks to ensure similarity is below 10% threshold. Impact, post publication is measured using scientometrics. And with this, we are over with Unit 5 publication. Uh, I will make the last video soon of Unit 6. I will post that. So go. That's it for today. Hope you guys like this video and share it with your friends and subscribe to my channel. Finally, 200 होने वाला है मेरे. Thanks, guys. और see you guys soon. Bye. Konnichiwa, guys. Welcome back to Learn with Endless. So today we are going to start with our last unit, Unit 6, Research Ethics of the course Research Methodology. And after this unit, we will be over with we will be over with this course. मतलब ऊपर ऊपर से तो हो गया. ठीक है. I will soon post the important questions too. Without any wasting any further time, let's get started with this unit first. Unit 6, Research Ethics. Learning objectives. After completing this unit, students will be able to understand the basic concepts, types, and processes of research, formulate the research problems, objectively, clear, and systematically, apply preparation methods and data collection techniques, analyze research data and present findings in a structured manner. Introduction to Research Ethics. Research ethics refers to the values, norms, and professional standards that guide how important research is planned, conducted, reported, and used. Importance of ethics in research. Equivalence to methodology. Importance of ethics are equivalence to methodology, maintaining public trust, and primary components. Equivalence to methodology. For students, ethics is important value as methodology because work that is technically sound loss all value if it is dishonest or cause harm to people, animals, or society. Maintaining public trust. High profile cases of misconduct, such as fabricated clinical data or falsified survey, lead to paper retractions, destroyed careers, and loss of public trust in science. Primary components. Ethical research focuses not focuses, it focuses on three major areas: professional codes of ethics, intellectual property rights (IPR), prevention of fraud and misconduct. Now, next subtopic: professional code of ethics. A professional code of ethics is a written set of principles and rules describing acceptable and unacceptable behaviors for researchers. Institutional guidance. Organizations such as Indian Council of Medical Research (ICRM), and the Institutional National Science Academy publish guidelines that university adopts. Core ethical principles: honesty, integrity, objectivity, respect for partners, beneficence, and non-maleficence. Let's go through them one by one. Honesty. Be truth and reporting data and methods, and do not falsify or omit results. Integrity. Follow instructions, keep promises, and do not switch techniques without proper justification. Objectivity. Avoid biases in experimental design and analysis. Disclose any conflicts of interest. Respect for person. Ensure informed, consistent privacy and confidentiality for participants. Treat colleagues and students fairly. Beneficence and non-maleficence aims to maximize good while minimizing harm to participants, animals, and environment. Here's a quick example for you guys. Reproducibility. Remember, the science is self-correcting because repetition is an inacceptable aspect of scientific process. Intellectual honesty. Researchers must aware of conduct thinking where people tend to ignore the evidence that contradicts their established theories. The peer review role. The peer review acts as a primary quantity assurance mechanism for journals, traditionally using anonymity to prevent pressure from influential authors. Water break. भी गला खराब हो गया है. Fuck. Sorry, I'm sorry. That was unfortunate. Research ethics represents the core principles, values, norms, and professional standards that govern the entire research lifestyle, from planning and data collection to final reporting and utilization. The why of research ethics. For university doing ethics is a fundamental as research methodology itself. It's for value preservation, public trust, and self-correlation. We have already discussed these points and the professional code in ethics, institutional guidelines, the major scientific body that guidelines that university adopts as their own principles. Indian Council of Medicinal Act, we have discussed these, Indian National Science Act, various international societies, core ethical principles, honesty, integrity, objectivity, and benevolence. We have discussed this one. This is a better tabular form. You can learn easily from the tabular form, and it looks nice on honestly it looks nice on question paper आंसर शीट सॉरी आंसर शीट में बढ़िया लगता है जल्दी बन जाता है ठीक है कर लेते हैं कि डिस्कस प्रिंसिपल core ethical principle honesty key requirements be truthful in report data and methods and findings prohibited behavior do not create falsify or omit integrity follow work instructions and keep promises prohibited behavior do not promise what you cannot deliver or switch techniques without reasoning objectivity minimize biases in design analysis and peer review do not ignore evidence that contradicts your hypothesis respect for persons. Maintain participant privacy and confidentiality. Do not conduct research without informed consent. Beneficiaries maximize benefits and minimize harm to subject. Do not ignore environmental impact or participant safety. Next subtopic quality assurance peer review. The peer review process acts as a primary quality control mechanism for academic journal evaluation. No reputable journal publishes the submission until it has been carefully examined by qualified colleagues. Anonymity. Traditionally, reviewers remain anonymous to prevent pressure from influential authors, ensuring the review is objective. Next subtopic intellectual honesty and conditioned thinking. Researchers must be vigilant against conditioned thinking, the human tendency to ignore evidence that contradicts established theories or personal beliefs. Objectivity. Scientists must be honest and objective even when they have no individual stake in the research proposal or manuscript they are reviewing. Openness or researcher must remain repetitive to brand new ideas and unexpected results. Example for you guys, the MRD link. In the exam, remember the introduction methods, results and discussion. Structure is designed to promote transparency and ethical reporting. The difference between fabrication and falsification. Fabrication. Making up results that never exist. Example, creating a table of data without running an experiment. Falsification. Manipulating existing data or material so the results are presented inaccurately. Example, removing bar data points to make graph look better. The 10% rule. Indian context, the UGC places on regulations 2018 states that 2018 states that the similarity index of less than 10% is generally acceptable for student thesis. Next subtopic, ethical responsibility to participants, colleagues, and society. The research is not conducted in a vacuum. It has real world consequences too. Researchers must navigate a complex web of obligations to ensure their work is beneficial and avoids harm. Responsible to human participants. When research involves human subjects, protecting their rights and welfare is the absolute priority. Voluntary and informed participants, and these are participants are protection from harm and right to privacy. Let's discuss them in detail. Voluntary and informed participation. Participants must choose to take part in the study without any coherence. They must be fully informed about the study's purpose, potential risks, and their right to withdraw at any time. Protection from harm. Researchers must ensure that participants are not subjected to physical, psychological, or social harm during the study. Right to privacy. The identity of participants and the information they provide must be kept confidential. Data should be anonymized whenever possible to prevent the linking of individual responses to specific people. Next subtopic responsibility to professional colleagues. Ethical research promotes a culture of trust and mutual respect within the academic community. These include honesty and transparency, giving proper credit, conflict of interest. Let's discuss them in detail. Honesty and transparency. Researchers must be perfectly truthful about their methods and research with their colleagues, giving proper credit. It is essential to acknowledge the contribution of all individuals who worked on the study. Salami slicing. Avoid splitting one large study into several small, thin papers just to increase your publication count. Authorship ethics. Only grant authorship to those who made significant contributions and do not exclude those who did. Conflict of interest. Any personal, financial, or professional relationship that could influence the study objectivity must be disclosed. Next topic, responsibility to society. Researchers should ultimately aim to improve human condition and the environment. Environmental impact. Researchers should plan their projects to minimize waste and their carbon footprint. Sustainable research techniques methods are preferred as they provide results with fewer resources. Social benefits are beneficial. The goal of any research project should be to maximize positive outcomes for the society while reducing potential negative effects. Public trust. By maintaining high ethical standards, researchers protect the reputation of their field and ensure the public continues to trust scientific findings. Here is a table summary of ethical pillars. Here are the stakeholders, participants, colleagues, society, key ethical responsibilities, and corrections. Participants inform their their main key ethical responsibilities inform consent and privacy, their core action protecting individual rights, data, and confidentiality. And for colleagues, integrity and fair credit, and their action is honesty, honest reporting, and proper authorship attribution. Stakeholder society, their responsibility, sustainability, and benefit, core action, minimizing environmental impact and maximizing social good. Here, example for your self-correcting nature of science. If an exam question asks you how fraud is detected, remember the repetition is the key. For fraudulent results are often exposed when other researchers fail to replicate the finding. Intellectual honesty. Be aware of the conditioned thinking, the tendency to ignore the data that contradicts your own theory. True scientific integrity requires being open to results you didn't expect. Impact versus integrity. While metrics like impact factor are important, they should never be prioritized over ethical rigor and accuracy. आपका भूख लग रही है. हाँ, Next topic, principles and ethics. Ethical research is built upon a foundation of core principles that ensure the safety of participants, the integrity of data, and the overall benefit to society. Number one, foundational ethical principles. Most professional code of ethics are built around several fundamental principles that every researcher must adhere to. And these principles are honesty, integrity, objectivity, respect for others, benefits, and non-violence. We have discussed in this earlier too, in earlier unit. Let's go through them again. Principle honesty and its key action, report data, methods, and findings truthfully without fabrication or omission. Why it matters? Because it ensures the research record is accurate and trustworthy. Integrity. Its key action is honor promises and agreements. Do not switch techniques mid-study without valid reason. It matters because it maintains consistency and professional reliability. Objectivity. Its key action is minimize personal biases in experimental data, design, data analysis, and peer review. It prevents personal beliefs from distorting scientific truth. Respect for person. Safeguard the privacy, confidentiality, and autonomy of human participants. It protects individual rights and personal dignity. Beneficiary. Aim to maximize positive outcomes and benefits of society for society. Ensures research contributes meaningfully to the world. Non-maleficent. Actively work to reduce or eliminate harm to participants and the environment. It prevents physical or psychological damage during research. Next topic, safeguarding participants. Protecting human and animal subjects is a non-negotiable ethical requirement in modern research, and these include informed consent, privacy and confidentiality, animal welfare. Let's go through them one by one. Informed consent. Researchers must provide potential participants with clear, understandable explanations regarding study's purpose, methods, risk, and benefits. Participants must be entirely voluntary. Privacy and confidentiality. Participants must be protected and data must be kept anonymous whenever possible. Animal welfare. In India, studies involving animals are strictly governed by institutional animal ethics committees, IACE, which enforce rigorous rules to prevent unnecessary suffering. Next topic, intellectual honesty and openness. A researcher's primary duty is to the truth, which requires constant self-awareness. Avoiding conditional thinking. Scientists must be wary of the tendency to ignore the evidence that contradicts their established theories or hypotheses. Scientific self-correction. Because repetition is the fundamental part of the scientific process, fraudulent or flawed results are eventually disclosed when other researchers fail to replicate. Next topic, peer review as an ethical barrier. The peer review referee process acts as a primary quality control mechanism for journals. Anonymous review. Traditionally, reviewers remain anonymous to prevent the pressure from influential authors, ensuring a objective evaluation based solely on the merit. Pre-publication validation. No reputable journal publishes a submission until it has been carefully qualified and deemed qualified by the qualified colleagues. Here is an interactive example for you guys. Define and differentiate. Be prepared to explain the difference between beneficence doing good and non-beneficent avoiding harm. Reproducibility link. If asked how science and Strong mentioned that self-correcting nature and about its applicability, even though exposure and ethical behavior, honesty versus bias. Remember that objectivity is not just about being fair. It's about actively disclosing conflicts of interest that could be subconscious influence your research. Next topic, intellectual property rights, IPR in research. Define its definition and core concept. Intellectual property rights (IPR) are exclusive legal rights granted for creations of mind, whenever, whether industrial, scientific, or artistic. Its control these rights allow creators to control the use of their work for a limited period purpose. The primary goal is to encourage innovation and reward original creative contributions. Next topic. Next subtopic, major categories of IPR. IPR is broadly divided into two categories: industrial property and copyrights and related rights. Industrial property includes patents, trademarks, industrial designs, geographical indications, plant varieties, and trade secrets. Copyright and related rights covers books, softwares, music, films, artistic works, and rights of performers and broadcasters. Next subtopic, why students should understand IPR. Research Research, even in small undergraduate projects, can lead to publishable or patentable ideas, such as low-cost solar water purifier, a new composite method, or an innovative app. Students should understand IPR because to avoid violation, protection strategy, and value recognition. Let's go through them in detail. Avoid violation. Help students avoid accidentally violating the rights of others, example copying codes or figures. Protection strategy helps researchers decide when to patent before publishing. Value recognition encourages students to recognize the professional value of their own innovation. Key IPR pillars in research. Number one, patents. Number two, copyrights. Number three, trademarks. Let's go through them one by one. Patents. Protecting inventions. A patent is an exclusive time-bound legal right granted for an invention. This mechanism, the patent can prevent others from making, using, or selling the invention in return for full public disclosure. In India, governed by the Indian Patent Act 1920. Terms in India, the term of patent is generally 20 years from filing the date. Copyrights. Protecting creative expression. Copyright safeguards creators of literary, artistic, musical, dramatic, and digital works. Coverage. In research, it protects the exact wording of paper, images, and software code. Duration. In India, generally lasts for author's lifetime plus 60 years. Fair dealing. Limited fair dealings is allowed for teaching, research, and criticism without permission, but it does not grant unrestricted freedom. Trademarks protecting brand identity. A trademark is a unique sign, word, phrase, logo, sound, or smell that distinguishes a company's product or services from others. Valid in India, trademarks are valid for 10 years and can be renewed indefinitely. Here's a table for major IPR types and its features protects example term granting body. Let's go through one by one. Protects patents plus two, new inventions and processes, copyright and for copyrights, original creativity expression, trademarks, brand names and logos. Example. Example for patents is a new chemical formula term 20 years from filing, granting body control journal of patents. For copyrights, protects original creative expression. Example, a research paper or software term lifetime plus 60 years, registrar of copyrights. Trademarks protects brand name and logos. Example, university or company logo term 10 years, but it is renewable indefinitely. Granting body registrar of trademarks. Next topic, international framework, the TRIPS agreement. The trade-related aspects of intellectual property rights, also called TRIPS, is most significant international agreement on IPR framework. It is the part of World Trade Organization (WTO) and came into force on January 1, 1995. Requirements: all WTO members countries, including India, must align their national laws with TRIPS provision. Here is an example tip for you guys. Patents versus publication. Always file a provisional patent before publishing your results in a journal. Publishing first can destroy the novelty required for the patent. Software protection. Software is typically protected as a literary work under copyright, though some aspects may be patentable. Open licensing. If using open source code like MIT or Apache licenses, ensure you follow the attribution requirements to retain ethical. Plagiarism versus copyright. Uncredited use of someone else's expression is both an ethical violation, plagiarism, and legal one, copyright infringement. Next topic, fraud and misconduct in science. Scientific fraud and misconduct represent a severe betrayal of the integrity of research. While rare cases, while rare, these willful frauds, willful frauds are absolutely unacceptable and can ruin the reputation of individual scientists and their fields. The FFP framework, major translations. The most scientific misconduct is categorized into three primary types, often referred to as FFP: translations, fabrication, and falsification. Let's go through the fabrication. Its definition: creating false data or results that never actually occur. Real-time example: a student who never ran an experiment but made up a full table of results for their thesis. Transgression falsification. Its main definition is manipulating research materials, equipment, or data or processes or changing omitted data. Real world example. Getting rid of data points that don't fit a hypothesis to make a graph look nicer. Transgression plagiarism. Definition: using someone else's work, ideas, or charts without proper credit. Real world example. Stealing another researcher's methodology or unique phrasing and passing it off as original work. Next topic, other questionable research practices, QRPs. Beyond FFP, there are gray zones, practices that are still unethical and unacceptable in professional research. And these are salami slicing, authorship misconduct, hidden conflicts of interest, sloppy documentation. Let's go through them one by one. Salami slicing, splitting one large comprehensive study into several small, thin papers to artificially inflate a publication count. Authorship misconduct, giving authorship credit to people who didn't contribute significantly or omitted those who did. Hidden conflicts of interest, not revealing financial or personal relationships that could subconsciously bias the results, studies research. Sloppy documentation, poorly recorded raw data so that it is impossible for others to verify the findings later. Next subtopic, how misconduct is detected. Science has a self-correcting nature. Fraud is typically exposed through replication failure, whistleblowers, and forensic analysis. Replication failure, when other scientists try to repeat the experiment and fail to get the same result, the original work comes under scrutiny. Whistleblowers, colleagues or students reporting observer unethical behavior. Forensic analysis, using digital tools to detect duplicated images or statistically impossible patterns in data tables. Next subtopic, institutional mechanisms and consequences. When allegations are made, universities follow structured investigation process. Preliminary stage, investigation, adjudication. Let's go through them one by one. A small committee reviews lab notes, emails, and raw data to determine if claim was has a merit. Investigation stage. An independent panel interviews involved parties and conducts a deep dive into all evidence. Adjudication. If found guilty, the consequences can include paper retractions, withholdings of degrees, freezing of funding, and permanent career restriction. Summary for research ethics. The Unit 6 emphasizes the pursuit of knowledge and must be balanced with moral responsibility. Its core mission, research ethics deal with values and professional standards that guides every stage of research from plan to reporting. Essential pillars, trustworthy science is built on honesty, integrity, objectivity, and respect for person. IPR compliances, respecting intellectual property rights, patents, copyrights, trademarks, is both legal and ethical requirement. Professional duty. Researchers have a duty to protect human participants, maintain fair relations with colleagues, and minimize negative environment impact. Integrity over expediency. Scientists must resist the publish or perish pressure and avoid shortcutting through fraudulent practices like FFP. Exam tip for you guys. The 10% similarity rule, we have discussed it numerous of times. In India, the UGCF Regulation 2018 generally considers a 10% without accepting exceeding to penalties. These for students. The authorship reminder, always ensure you cite every source you uncredited use of another experience. Another's expression is both a copyright violation and plagiarism. Study gray zones, be prepared to explain why salami slices is harmful. It cuts the literature and wastes resources, even if data itself is real. Here is a quiz for yours. I have solved it. It's just for revision. Research ethics is best defined as the values and norms and professional standards that guide research. Explanation. Research ethics encompasses the fundamental values and standards that govern every stage of research, from planning and execution to reporting and final application, ensuring the integrity of the scientific process. Which core principle requires researchers to perfectly truthful about their result and give proper credit to colleagues? Honesty. Honesty is non-negotiable requirement in research. It involves being truthful about findings, acknowledging the contributions of fellow researchers, and being transparent about procedures followed. Objectivity in research means that a researcher is not swayed by the personal preferences, preconceptions, or what others think. Explanation. Objectivity requires researchers to rely solely on facts, logic, reasoning, rather than being influenced by personal biases or external processes that might distort the interpretation of data. The primary quality assurance mechanism for academic journal is peer review. Peer review involves having qualified colleagues scrutinize a manuscript before publications to ensure it meets the necessary scientific and ethical standards. What is conditioned thinking? In a context of research ethics, a tendency to ignore the evidence that contradicts established theories. Explanation. Conditioned thinking is an ethical hurdle where researchers may subconsciously overlook or dismiss data that challenges their existing beliefs or theories. Intellectual property rights (IPR) are granted for creations of mind, such as inventions and artistic work. Explanation: IPR covers legal rights for original intellectual outputs, including patents for inventions and copyrights for literary or artistic works, providing creators with control over their innovation. In India, patent for invention is generally valid for 20 years from the date of filing. Explanation: under the Indian Patents Act, the standard term for the patent is 20 years from the date the application was filed. Which of the following is considered willful fraud in science? Falsifying or fabricating data. While mistakes can happen, fabrication, making up data, and falsification, manipulating data are deliberate acts of misconduct that betray scientific integrity. Salami slicing in research refers to splitting one large study into several small thin papers to increase publication count. Salami slicing is an unethical practice where a single comprehensive study is broken into multiple minor publications just to artificially inflate a researcher's resume. According to the text, science is self-correcting because repetition, replication eventually exposes flaws or flawed or fraudulent results. Because scientific progress relies on other researchers being able to replicate findings, errors, or frauds are eventually discovered when results cannot be reproduced by independent studies. Here is a summary table for the pillars of research ethics. Principle Integrity, consistency, and sincerity in thought and action. It is important because it builds trust within the scientific community. Verifiability, presenting results so others can check their accuracy, allows for independent verification of facts. Replicability, the ability for others to repeat the study and reach similar conclusions, forms the basis of generalized knowledge. Persistence, continuing the study despite setbacks and false starts, essentially for completing substantial process. Anyway, with this, we are over with Unit 6 and we are through with this course. All the best for your exams next month. Regards, your sir, Hardik. ठीक है uh, हो गया और if you like this video do share with your friends and subscribe to my channel मुझे भूख लग रही है मैं जा रहा हूँ बाय ब्रेकफास्ट करने 5:30 बज रहे हैं सुबह के मुझे भूख लग रही है ठीक है बाकी दिस इज माय यूट्यूब चैनल मेरा इंस्टा भी है इफ यू वांट यू कैन डीएम मी बाकी इफ यू गाइस वांट नोट्स किसको नोट्स चाहिए तो टेलीग्राम का चैनल है नोट्स पेड है ठीक है बाकी नोट्स चाहिए तो यू कैन ऑल्सो कॉन्टैक्ट मी ऑन माई ईमेल आई मेंशन द ईमेल on my YouTube channel. You can contact me via my mail. बाकी जिसके पास मेरा नंबर है वो मुझे कॉल कर सकता है मैं उसे शेयर कर दूंगा नोट्स पेड है नोट्स और ठीक है बाकी हो गए हैं और अगर कोई और टॉपिक्स पे चाहिए तो मुझे बता दो मैं बना दूंगा पढ़ना पड़ेंगे वो तो है ठीक है विद दिस खत्म हो गया भाई ठीक है चलो सी यू गाइस सून अब नेक्स्ट कोर्स में मिलेंगे अगली यूनिट में मिलेंगे चलो बाय तब के लिए टाटा बाय बाय